Hello and welcome to the micro lecture on data visualization. This micro lecture should enable you to understand and explain the importance of data visualization. Moreover, you should be able to recognize and distinguish common types of data visualizations, meaning knowing different kind of plots you can use. And finally, to compare the strengths and weaknesses of the different kinds of data visualizations, meaning that you know when to apply what kind of plot and what advantages and disadvantages this entails. To achieve our learning goals, we would start with some reasons for data visualization, meaning why do you need it and when is it specifically useful. Then we will talk about different kind of plots, like scatter plots, box plots, etc. And in the end of this micro lecture, you will learn something about the plot structure. To visualize your data can be very useful in different steps of the data mining process. In the beginning, it can help you develop an understanding of your data. For example, if you have a good plot, you can usually see the minimum value, the maximum value, and the data distribution. It can also help you to recognize patterns or correlations among the data, meaning if you plot two variables against each other, you can usually see if there's a dependency or not. It can also be useful to identify errors or outliers. For example, if you plot a timeline and then you have a date that's in the future or way in the past that should not have been recorded, then this usually signifies that it's an error. And after you've done your thorough data mining process, it also is very useful to communicate your results. Most often the people that are interested in the results are not very interested in the process or in the steps you did to get there. Thus, it can help you to convey key points of your findings and not bore them with details on statistics or machine learning processes. One of the probably most intuitive ways to plot two numerical variables against each other is to use a scatter plot. It displays every single data point as points in a plot, and it is very helpful to show a relationship or correlation. The relation can either be linear, exponential, also just non-existent. And if there is a correlation, it is important to see if it's positive or negative. For example, on the pictures on the right-hand side, down in the corner, you can clearly see a linear relation. The data that is plotted there is from a sales representative data set. And you can see that the higher the leads number of a sales representative, also the higher is their sales number. Then what you can also do in scatter plots is that you plot another variable which does not even need to be numerical, and to colorize your data points. Here in the plot, for example, it also shows if the representative is male or female. And as you can also see in the plot, the gender does not have an effect on either the leads number or the sales number. So this is a very intuitive way to gather first information about the relationship of two variables. Another very intuitive way to visualize data are bar plots. Bar plots usually compare categorical variables against a numerical value. In this case, we also work with the sales representative data set again. It plots the sale frequency versus the day of the week, like Monday, Tuesday, Wednesday, etc. And also, which is not usual for a basic bar plot, against another categorical variable, which are the seasons, like spring, summer, autumn, winter. And here from the bar plot, for example, you can see that the sales number does not vary much across the day of the week. However, you can see that the sales in winter are usually lower than the sales in spring and summer. And yeah, usually bar plots compare the frequency or count across different categories. And on the right hand side, it's a vertical bar plot, but they can also be horizontal. Line plots are similar to scatter plots, except that the single data points are connected by a line. So they are usually used to show trends or developments in general. And there's also oftentimes not a single line, but multiple lines whose development you can compare with the graph. Box plots are very useful to compare the distribution of data. They display the distribution of a numerical variable, also sometimes depending on another categorical variable, like in the figure on the right-hand side. What is useful about box plot is that they contain very much information. They contain the median of the data sample, meaning if you order numerical values, then it's the one in the middle. And they also display the minimum and maximum value, they display outliers, and they display also the quartiles. Meaning, for example, that within the colored boxes, there lie 50% of the data. So, for example, if you look at the graph of Asia, you can say that on average, the country tax in Asia is like 11, and that 50% of the country taxes in Asia are between 18 and 5.5, and that no country tax in Asia is below 5 or above 20. Sometimes it's not possible to create box plots because you need a certain number of data points. This is why we probably don't have box plots for South America, for example. And they are very useful because they can provide information about the variability and the skewness of data. Meaning, for example, if you have many high values or many low values, or in general, if the data spread is very high or low. As the name suggests, distribution plots are very useful to visualize a distribution of a numerical variable. And they actually contain two kinds of plots: a kernel density estimate, which is basically a line plot, and a histogram, which is basically a bar plot. And the histogram shows the frequency of values within certain intervals. You can also predefine the intervals, or the histogram does it automatically. And the kernel density estimate is a smoothed line that approximates the probability density function of the variable. Heat maps are very useful if you have many variables within your dataset and want to get a first glimpse of the correlations among those variables. The table on the right-hand side usually don't see, it's just created internally, but it calculates the correlation between each of the numerical variables and all the other numerical variables. Obviously, the correlation between each variable and itself is 1. That is why there are only 1s in the diagonal of the heat map. And the heat map is also symmetrical because it just repeats itself if you compare every variable with every variable. And it's usually color-coded, so you can see on the first side which variables have a very strong correlation. You can also define within the function which kind of correlation it should calculate. So it's a very useful tool to get a first overview of your dataset. After having talked about different kinds of plots, we will talk about the general structure of a plot. That is important if you want to create plots by your own. Every plot basically consists of a y-axis and an x-axis, which always should be labeled. So you should always have a y label and an x label. And then for better data understanding, it's always recommendable to have labels of the ticks, so of the y ticks and of the x ticks. And yeah, it's also important that your plot has a title, so that someone looking at it can immediately see what it displays. Sometimes, for example, if you have different colors, it might be very advisable to have a legend. Yeah, it's a possibility to contain very much information in one plot is to create subplots. So basically, you make one plot out of multiple plots. You can do this with either plots of the same type, but as you can see on the right hand side, it does not need to be necessarily the same type. This is very useful to have all the information in the plots on one visible point, so it conveys a message. Thank you very much for listening. I hope this micro lecture helped you to understand the importance of data visualization, and that you are now able to recognize and distinguish common types like scatter plots, bar plots, box plots, heat maps, and that you are also aware of their strengths and weaknesses and when to use them. For example, if you have numerical values, then it's better to use a scatter plot, and if you have categorical values with, for example, different data distributions, then you could use a box plot. Thank you for your attention.